Hello and welcome to the Digital Lighthouse, where we get inspiration from tech leaders to help us navigate the exciting and ever-evolving world of digital transformation. I'm Zoe Cunningham. We believe that meaningful conversations can illuminate the path forward, helping us harness the power of technology for innovation, scalability and sustainability. On this episode, I'm thrilled to be chatting with Jamie Dobson. Jamie is the founder of cloud consultancy Container Solutions, where he served as CEO for 10 years before handing over the reins in 2024. Jamie has an extensive background building large cloud platforms across a range of industries from travel to banking. Along with Michelle Ginau and Pini Resnick, Jamie co-authored Cloud Native Transformation, Practical Patterns for Innovation, a guide to transforming your organisation into a cloud-native enterprise, both architecturally and culturally. In this episode, we'll be chatting through topics from Jamie's new book, Visionaries, Rebels and Machines, from the invention of the building blocks of technology we use today to how these same principles underpin the artificial intelligence that we can predict right now will shape our future. Jamie will share with us how advances in people management and leadership were as essential as the scientific advances and how both together culminated in our interconnected world of today. So, Jamie, welcome to the Digital Lighthouse. Jamie, you started your career as a technologist working for consultancies like Accenture. Can you tell me about your journey to starting and building up Container Solutions and what you learned along the way?
I became a consultant quite by accident. Originally, I was a computer programmer, so that was my chosen career path. That's what I enjoyed doing as a kid and as a student. But of course, I entered the world of work, more or less at the time that the World Wide Web exploded onto the scene. So all of a sudden, the lone programmer no longer existed. We were forced to work in teams with people who did the front end, designed user journeys, people who hosted the software we wrote. And so myself and many other colleagues were kind of thrust into teams for the very first time. So you start to see the rise of extreme programming, the agile software delivery methods, and that spoke to me. And when I moved to Accenture, there was a specific reason for that, which was I wanted to get my hands on big systems for big companies. In other words, to move away from the startup world I'd been occupying. And once I started that, I started to think, there's a different way to do consulting. And in the end, that became the genesis of Container Solutions.
Tell us a bit about your different way of doing consulting then.
Well, as being customer-centric, now that might seem quite a modern concept. I've seen some appalling, I cannot name names, of course, but there's an ethical problem with consultancy that sometimes if you do a bad job, you end up getting more fees to correct your previous errors. And so there's an incentive on the consultant side to, drag the project on for as long as possible. So there's a real ethical challenge there. So for me, there were two sides of it. The customer side of it, so working collaboratively with our customers, including project inception, sitting around the table and looking about what has to happen and how do we hand over the work we've done. So in other words, how do we help our customers build their own capability? So I was always a big believer in that. There's a current backlash in both the United States and the United Kingdom against consultancies because governments should build their own capabilities. There's no pushback from me on that one. I think that's right. And then on the other hand, there was this ridiculous notion that you shouldn't train your people too much because if your consultants became too skilled, they would pick up and leave.
Right.
And of course, the idea is, well, what happens if they don't have the skills for the job? So Container Solutions was a bit like a university. So drawing on all those wonderful heroes of mine from Xerox PARC and even the work that Oppenheimer did in the desert, Container Solutions was always meant to be a learning organisation on the one hand and very customer-centric on the other.
Yeah, and like you say, it's because software started in 2000, right? And when we started, we had principles like, it's got to be done this way, which wasn't common. And it's actually quite gratifying, isn't it, to see the industry move and go, oh, okay, actually everyone wants to do it this way now. And that's a good thing.
It's nice to be right. It's nice to be right. And I was told, you won't succeed. You're idealistic. You don't understand the real world. You don't live in the real world, was what I used to get all the time. And I'm about to like, well, I'm pretty certain I do live in the real world. And of course, I was only young, so I probably took that feedback to heart. That being said, that was the catalyst I needed to go and prove these people wrong. And in the end, I think we did a good job of proving them all wrong.
Brilliant. Well, moving on from container solutions to your new book. So congratulations on releasing Visionaries, Rebels and Machines. The first thing that struck me right from the moment that I started reading was what a deep and comprehensive history of technology you've put together. So was this history that you knew already from your time as a technologist? Was it things you'd picked up? Or did you have to research like the early discoveries like vacuum tube radios and sticking together transistors to make a microchip?
Well, like a fool, if you'd have asked me that question 5 years ago, I'd have said, I think I more or less know the timeline. And so I don't need to do much research. That's how I started writing the book. But actually, looking back and looking at the references, I've done a tremendous amount of research. But the big blocks were there. Edison, at the beginning, Edison was always meant to be the beginning. But actually, I had to take one step further into the past to talk about Galvani and Volta, because in my opinion, that was the beginning of the separation of neurology as a study and electrical engineering. They came back together in the perceptron in the 1950s and 60s, in my opinion. So the building blocks were there, but there was one thing I definitely didn't know and I was scared of, which is how do transistors work? So I'm a computer programmer. I'm scared of electronics. So I've been meaning ever since I was an undergrad to sort of kick the tires on transistors, and I've been putting it off for 30 years. And so with this book was really right, you're going to go and learn about transistors. And then the second thing, there was an unknown. I didn't fully understand the relationship between the early psychologists and specifically Licklider, who worked for the Advanced Research Projects Agency, and how that sort of bridged usability and all the things he put in motion would become the personal computer. There was a JCR Licklider shape missing in my mind that I didn't know about. And as to the transistors, what a disappointment that was. So basically the answer's dead easy. You got a light bulb, somebody stuck a wire in to make a diode, and that could be used as a switch. Somebody stuck a third wire in, so it could be used as a dimmer switch. And then William Shockley and his team shrank it, and at that moment, the vacuum tube became the transistor. And if you've got millions of them, you've got a microchip. I was like, oh my God, I've been worried about that for years.
Yeah. I had tremendous fun reading your book, and it sounds like it must have been tremendous fun, like researching it and finding these things out. What was the most interesting thing that you discovered?
I think on the people side, Robert Oppenheimer as a manager, I think that's very interesting. So people think of Oppenheimer as, now I become death, the destroyer of worlds and all of that. And the recent film with Christopher Nolan. But what you see in Los Alamos is very subtle things. Creating creches, because a lot of the physicists' wives were either working there or they were growing their own families. So what practical things did Oppie need to sort of put in place so that his team could get on with their lives? And so you see that. You don't think of Edison as a manager. He was a fantastic manager as well. So that was something that jumped out. A second thing, I think I knew it somewhere, but I couldn't articulate it. Who invents a system? Is it the person who invents a component, the microphone, which is what Thomas Edison did? Is it the person who brings all of these components together, which Edison did do at Menlo Park? But Edison had no idea that his system for dividing light would be used to plug in toasters, not long after that radios, etc., etc. So it's the use cases that brought the grid to life. So does that mean we're the inventors, the users? And then you saw that again with AWS. They had a cloud, you could log in and buy storage and some compute, but only once it got into our hands, the users of AWS, did Amazon start to really understand where this thing can go. So I think that's, I don't know if I didn't know that, but it was nice to say, actually, there's these three progressions, and we probably underestimate the impact of the users and the creativity of businessmen linking real user needs on the one hand with technology on the other.
Yeah, and it's like you said at the start, right? This idea we have of a lone programmer, coding a system, that's not how it works at all, right? It's very much a team sport and a team process. And all of these, like you say, these great inventions, they're not really the product of one person. They're the product of one person within a society linking in with, tens or hundreds of other people.
Well, the thing about Thomas Edison is he's vilified, I think, very unfairly, and he's also held up as an exemplar of the lone inventor. This is exactly the opposite of the truth. What he did at Menlo Park was have teams and teams of people so he could run more experiments in parallel. So without an ability to manage the team and manage the politics and the dynamics, he could have never had parallel invention. So the reason why he beat the Englishman Joseph Swan to the punch with the incandescent light bulb is because Swan was a lone inventor, and Edison could innovate with vacuums, with filaments, with the grid in parallel. You see that today, the big companies can run experiments in parallel. That's what Netflix do. That's what Google do.
I feel like we're going super fast just thinking through history and how fast everything was going, but it just keeps going faster and faster. And it feels like we're kind of flat out. And I think the temptation is to let things drop by the wayside. Like, I don't really have time to learn about the history of technology because I've got so much going on right now. But what are the things that it is important that we know and we remember as technologists using that when we build things going forwards?
It's a good question. Are things really moving quicker, or is there an illusion that things are going quicker? So when the radio came out, by the time you bought a radio and stuck it on your shelf because it was big, it had vacuum tubes in the back, it was instantly out of date. So the same challenges you have with flat screen TVs now, every time you buy one, next year's is almost certainly going to be better. Well, that happens pre-Moore's law. So you see people complaining about the insane rate of change with electrification of society, and then when we brought radios in, and then when we brought televisions in. So there's something about things changing that make you feel it's accelerated. At the other end of the spectrum, though, there is something that is specific. Artificial neural networks basically need more data and more computing power to make them more powerful. And because of Moore's law, we do get exponentially more computing power all the time. So they are moving at a breakneck speed. That being said, if you look at the lifetime of artificial neural networks, it's pretty slow. It's the conclusion that we cannot get computers to simulate the brain. So why don't we flip it around and try to borrow from the brain to create these systems? That happened in the 1950s. And then got the back propagation of errors in about 1983, so you could work back through the network. And then, the web basically created a way for us to create lots of data. So for that, we needed digital cameras. So actually, it's quite a slow process to get to the artificial neural networks of today. But things are moving quickly, yeah. And I think things are changing quickly. When you throw in the cost of living crisis, I've got a book from 1906 that if you cross out the technologies they talk about, you see the rise of populism, the rise of communism. Left-wing populists blame the rich, right-wing populists blame immigrants or a minority. Now, I could write cloud in there or artificial intelligence, and that book would still make sense today. So these technologies change, but human nature and our societal reaction to corporate greed has not changed at all.
Yeah. That's a great answer as well, right? If you remember one thing from history, it's that everything is not as new and different as you think it is. Our times are not as unprecedented. Everyone throughout history always thought they were living in unprecedented. Well, and they kind of were, right? Because everything's always been changing and everything's always new.
It's remarkable. So So this was a big theme. Technology changes, human nature doesn't. As soon as we
Mm,
had electronic technologies, we used them to amplify messages. So people are talking about social media and the use of governments to shape public opinion. As soon as the transistor radio came out, that's exactly what British propagandists did. And then the Nazi Party did that to remarkable effect. They gave everybody a free
mm,
radio and used it to change the mood of the whole nation, to prepare the nation for conflict. So this is not new. This idea of taking propaganda and splicing it together with electronic technology is not new. And we've solved the problem already. A lot of the solutions, apply right now.
hmm I'm just rattling through it because there's so much interesting content in your book. A quote that jumped out at me was, "Developers are alchemists, and our job is to do everything we can to get them to do their alchemy," which Jeff Bezos said from Amazon. As a developer, I thoroughly agree with that sentiment. How does it lead to the creation of cloud computing?
So the original alchemists were Thomas Edison. They changed science and engineering into dollars, pure, pure gold. The new alchemists changed silicon, sand into digital dollars. So that the Bezos has almost certainly stolen that expression from a 1982 book about the rise of the microchips. But basically, he was doing a nutter. Now, that's not a Yorkshireism. That's what journalists describe Jeff Bezos as doing when he chucks a tantrum. So Bezos comes to the conclusion that innovation at Amazon is limited by how quickly they can get features under the noses of a customer. So whether that's one click, the auto saving of addresses, basic A/B testing, very quickly they realize that, well, if we cannot provide new features and if we can't scale up our infrastructure, we're going to lose people because there's only so many people can log in at any one time. So the bottleneck in infrastructure and software development became almost one-on-one or synonymous with innovation at Amazon. That then became Bezos' sort of catchphrase: developers are alchemy, and we, and by we he means those managers, those business people, we have to do everything we can so that they could do their alchemy. We've got to pull down all these barriers. And the only barriers really at Amazon were computer infrastructure. And that's therefore the beginning of APIs to provision software and infrastructure. It's the famous memo where Bezos said, anybody who doesn't use APIs to provision their stuff, I'm going to fire you instantly.
hmm
And a couple of years after that, after they started to really solve the IT infrastructure bottleneck, it hit them, well, if we've solved that for ourselves, maybe we could sell that as a service. And so that goes all the way back to Edison, where what he was actually doing was creating lighting as a service. All of a sudden, you've got computers as a service. So those parallels between Edison and Bezos in that regard, they hold.
Mm. And right now, after all these great inventions of the past, we're going through this technological change as large language models change how we write and how we create. We've already kind of alluded to it already. What do you think the implications of the history of technology are for the current AI transition? I suppose specifically, if you're a CTO or a CEO talking to your CTO and you want to be like, how can I best prepare for AI? What can we learn from history to support that?
So I think the number one lesson, we start with Theodore Vail. So Ted Vail helped to bring Alexander Graham Bell's telephone company to life, but then he was ousted because the lawyers took over and they were all about protecting their patents and exploiting them for forever. And Vail was like, if we don't innovate, we die. They brought him back in desperation in 1907. The very first thing he did was fire all the lawyers and the traditional managers, and he brought what I've called telephone native leaders. So people who understood telephony and understood human nature. So right now, I'm personally assisting or advising a number of companies, and I don't need Theodore Vail to teach me this, but I'm like, you've got managers who came up in the time of web development. They don't know anything about cloud computing. They certainly don't know anything about artificial intelligence. So if you don't have people who are, either born in these eras or at least understand how they work, you're going to struggle because you're managing your business as if it was 20 years ago, and that's just doesn't make sense anymore. So I think the first thing is, what does a capability look like and how do you go about building it? Everybody at Container Solutions is really savvy with the cloud. That's what we do.
Right, it's your job, like, yeah.
It's literally our job. So people have got to build those capabilities, identify those managers, and it's a bit boring, but a little bit of strategic human resource. What type of people do you need now? What type of people do you need in a year from now? And what are you going to do to close the gap on that? So that's pretty traditional HR stuff, but it's necessary. The second thing is the use case question. So if history teaches us anything, it's that it won't be the creators of these large language models that will dictate where we go with this, but it will be the users. This has already started to happen. Large language models trained on medical data, specifically how you react from a heart attack or the symptoms that lead into that. So you've now got LLMs that will give you a better answer about, your patient's heart condition than ever before. That's a classic use case. So certainly ChatGPT or the people behind the technology didn't think that this was going to be use case, but boom, there you go. We've now got a stethoscope, and this is really interesting because history, God almighty, repeats itself as total farce. The stethoscope itself was originally rejected because doctors said, if you can't understand your patient's breathing with your own ears, if you can't put your ear on their chest like this and understand it, you're not a real doctor. So it took decades for the stethoscope to be accepted as a tool. Well, anyway, nowadays there's a modern stethoscope. It's a bit like the original, except it sends the data back to a cloud computer where there's a large language model trained on lots of stethoscope data, and it will quickly say, this person has the risk for this, this person is suffering from this, and it does so much more accurately than the doctor alone and an old-fashioned stethoscope can do. So it's already started. The future will be dictated by the users. So I think those are probably the two big ones for me. The third one, what we're going to do when all these people become unemployed. It's coming. It's 100% coming. When Henry Ford's motor car took off, 20% of all grains grown in America at the turn of the last century went to feeding horses. 20%.
Wow.
There was a cottage industry in people. Can I swear? Am I allowed to swear? Horse manure. All the streets were caked in horse manure and people had to clean it up. And they cleaned it up into 2-metre piles at the end of every street. So if you imagine Broadway or maybe the Mall here in London, just about 140 years ago, and a lovely upper-class ladies walking with their parasols, you can picture that scene easily. But what you can't picture just off camera, as it were, is piles and piles and piles of horse manure. So this is a kind of comical way to say one industry came to an end. The rise of LLMs is going to bring industries to an end. And even if they don't bring them to an end quickly, the people planning the next rounds of businesses are banking on these technologies working. This is why society is currently frustrated. The cost of living's going up, unemployment's going up, people are holding budgets in cloud computing. People are confused. For the first time, computer programmers are finally feeling what it means like to have a precarious income. Because for the last 30 years, we had a great party. And all of a sudden, people I know who have never had an issue getting a job are asking me, hey, have you got anything going right now? Because I can't find a job. I've been unemployed for 6, 9, 12 months. That's unheard of if you're a talented technologist. So the world has changed right in front of us.
Yeah. And things don't get, I think sometimes we assume things will get better on their own. And actually, unless we make a concerted effort, that's not what happens.
And there's precedent for that because the underground in Paris and London, the municipal public transport in both New York and Zurich and Vienna was put together not by radical leftists. They were all put together as a way to bring social justice because so much money was being consolidated in so few hands. These people were not woke left nutcases. That's not the words I'd use to describe it, by the way. What I'm trying to say is that it was sensible politics to try to avoid civil unrest. So everything that's happening right now has happened before. Let's see if we've got any parliamentarians who are willing to sort of learn something from their great-grandparents.
Yeah. Absolutely. Well, just quickly, where can people get hold of your book and what's next for you?
The book is available on all good bookstores. I think there's about 3 copies of the hardback left and they're all signed. So if people want to grab them, they can. what's next for me is something slightly experimental. I got it into my head, maybe it was reading about the radio and the 1950s, to do a sort of single narrator podcast. And I'm going to use that to expand Visionaries, Rebels and Machines. So, for example, I mentioned Theodore Vail today. He doesn't really appear in the book. He deserves his own podcast episode, as it were. And what I'm learning is it's quite challenging to script that, record that. I thought I'd burn to an episode every 3 days.
Yeah.
I can't even tell you how stupid that now looks in hindsight. So that's what I'm going to be doing. I'm still really enjoying consulting at Container Solutions. I deal with our most difficult customer issues. I love that, but I don't have any managerial responsibilities. So I think a bit of podcasting, bit of consulting, and try to enjoy it. I'm not very good at that, but I'll just try to enjoy this change of pace. And 2026, who knows?
Brilliant. Well, thank you so much for writing the book and for coming on and sharing it with us. The Digital Lighthouse was edited by Steve Bolland and produced by Patrick Anderson. The theme music was written and recorded by Ben Balow. A huge thanks to our sponsor Softwire for their continuing support from the inception of the show in 2019 right up to the present day. If you love the podcast, please let us know with a rating and a review on your platform of choice. We're always looking for feedback to ensure we're making the best show possible. And if you'd like to take part, please drop us a line at thedigitallighthouse@softwire.com. You've been listening to The Digital Lighthouse with me, Zoe Cunningham. Thank you for sharing your time with us, and stay safe on this wild technological ride that we're all on.